Hello, this is Algebra 2, Chapter 6, Section 5. We're on page 3 of the notes. We have this little box that's meant to help us understand the rules about graphs of radical functions. And they have two general forms, a times the square root of x minus h plus k, and then also a times the cube root of x minus h plus k. But really it's the same idea, because what we need to do here is we need to go ahead and sketch the graph of y equals a square root x or y equals a cube root x. Back in the prior example, they were talking about it being a vertical stretch or a vertical squeeze, depending on the value of a. That's true, but we're getting started with supposing that that has already happened. Then the second step is to translate the graph h units horizontally and k units vertically. This is very similar to what vertex form of a parabola looked like, and also when we had those absolute value functions that we were shifting left and right and up and down. The ball game is the same. The tricky thing, as always, it's not a new tricky thing, it's an old tricky thing, is that for the stuff inside the function, the minus h, the minus is built in. Remember, it's the square root's kind of like a set of parentheses in this, and I've been kind of harping all year that everything in parentheses is backwards from how you think it should be. That's still true. Hey, so if we go down to example 3, we've got a nice square root graph. It's multiplied by 3 in front. It's minus 1 inside the square root, plus 2, then state the domain and range. Now, they say, first of all, sketch the graph of y equals 3 squared x. So I'm going to do that here. And it says, notice that it begins at the origin, because square root graphs do begin at the origin. And it goes through the point 1, 3. And that's probably pretty okay for you, in that if you thought about sticking 1 into the square root, you would get 1, and then times 3 is 3, so the y value is 3. So you've got that, and then you just kind of take off and go ahead and some sort of square root graph out of that. Then lost that point. There we go. Okay, so that's the basic square root thing. But now we want actually this much more complicated version. Well, it says x minus 1 inside, so h equals 1, and k equals 2. So we shift the graph, we shift it right 1 and up 2. Right, so that minus 1 inside the radical, that went to the right, positive on the x's, positive 1, and then that plus 2 on the outside does shift it up to plus 2. So the resulting graph starts at, they used to start at the origin, but since you've gone right 1 and up 2, it now starts at 1, 2. And then if you use that other point they gave us, 1, 3, from the first graph, move those numbers right 1 and up 2, you get 2, 5. So I've kind of circled these points to say they're kind of like some other key point that you may have noticed and gotten in on, and then they correspond to each other. Alright, so good times. Let's go ahead and graph that. It starts at 1, 2, and it goes through the point 2, 5. And so then we know, like that. It's the same graph as the blue one. Right? My red graph there is the same one as the blue one. It's just been moved right 1 and up 2. Okay. Probably annoying to think about at first. Not going to kill you, though. But now we got to do this domain thing. You're really better off if you do the domain after you've made the graph, because then you're like, okay, looking at that, domain is an x thing. So let's see here. In green, I'm going to draw that the x's start at 1 and they kind of go forever to the right. If you're looking at that nice red graph, the x's start at 1. So the domain is going to be x is greater than or equal to 1. And then for the range, again, we're looking at that red graph. The range, the y's start at 2 and they go up forever. So the range is y is greater than or equal to 2. There you go. That's the situation for example 3. Thank you for watching.